Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. And here now I will explain you IR spectra. In this chapter, this is lecture number 2. And again it is an introduction. And in this lecture I will explain you vibrations of molecule. In the first lecture also I explained you that when two atoms like hydrogen and chlorine approach each other for bond formation from infinite distance, then first of all, they approach each other because of attraction. And when they come closer, then overlapping of atomic orbitals takes place according to valence bond theory. When these two atoms attract each other, they overlap their orbitals and they may reach to this R1 distance where repulsion is greater than attraction and overlapping is much more. So R1 distance is not a distance where they are stable because repulsion is greater than attraction. And therefore they will move ahead and they will go away from each other and will reach to this distance R2 where attraction is greater than repulsion. That means at this distance attraction is greater than repulsion and overlapping is very less. So even they are not stable over here. From this R2 distance they will again move to R1 distance, from R1 to R2 and R2 to R1. So this way when a molecule becomes stable, but within molecule atoms are not stable and they keep on moving from R1 to R2, R2 to R1, and that is called vibrationals. This is fundamental vibrationals, vibrations of molecule. So atom is stable, but molecule is stable, but atoms within molecules are not stationary, they keep on moving. So we have to assume one distance which is between R1 and R2, that is R0, where force of attraction and repulsion should be equal, which we'll never get it. So how to obtain it? By average. So we know R1, we know R2, then we take the average of these two, which is called average bond length. So HCl is stable. It is assumption that HCl is stable at R0 distance and they form a bond, okay, which practically not possible to gain. Anyway, these are the different types of overlapping of atomic orbitals. Now we have to explain the same thing with graph. So this graph is plotted. Here on x-axis we'll put distance between atoms and E is energy on y-axis. Okay. At present, both hydrogen and chlorine are at infinite distance, so they are outside this arrow. Okay, where there is attraction, there is no attraction or repulsion among them. But by chance, when hydrogen approach chlorine because of mobility, then they attract each other, then they are coming close to each other. So we move from right side to left side on x-axis because distance decreases from right to left. And when hydrogen and chlorine are forming bond, that distance decreases and therefore we have to approach from right to left. At that time, attraction is greater than repulsion, so we assume that energy decreases. And therefore, we move top to bottom on y-axis. So now with this graph, we go from infinite distance to finite distance and with loss of energy. So this may be the distance where force of attraction is equal to force of repulsion, and this graph will be from hydrogen to chlorine from here. It begins from here and which will reach to this distance where attraction is equal to repulsion, and this is R0 distance. Okay, but we know that atoms are not stable or not available over here. So when they cross limit and reach to this R1 distance where repulsion is greater than attraction, so the graph will move like this. Okay, so finally, we reach here R1 distance where repulsion is greater than attraction, and therefore H and Cl will go from R1 to R2 distance where attraction is again greater than repulsion. So this way, at hydrogen and chlorine will vibrate between R1 and R2, and therefore this is known as basic vibrational level, between which atoms within a molecule without absorption of energy keep on vibrating, and so it is called ground state also. Okay, so it is between R1 and R2, keep on this molecule keep on vibrating between these two distance, and R0 will be an imaginary average distance. Okay, so this is the graph where would this thing happen. Okay, now when this molecule absorb infrared radiations, then what happens? Let us see this one. So here molecules absorb HCl, for example, absorb infrared radiation. Then what happened? Let us see this one. So before that we should know what is infrared. It is the fraction of electromagnetic radiation. Okay. So first of all we have infrared and then microwave. So we have to see what is the combination effect of infrared along with microwave. Infrared is on the left hand side of EMR, therefore it is having higher energy, and microwave is having lower energy with reference to infrared. Microwave can produce effect of rotations, so it can change rotations of molecule, and infrared can change vibrations of molecule, because it requires higher energy. Vibrations require higher energy than infrared, or sorry, microwave. So here, when molecule absorb only microwave, then it can change only rotations of molecule. That is, change in rotational levels appear with reference to center of gravity. Okay, but when molecule absorb infraradiations, infrared radiations, IR radiations, then because of high energy, it can change rotations, because rotations require less energy. So you find change in rotations as well as vibrations. Okay, that is change in rotational levels as well as change in vibrational levels. This changes produce bunch of lines. Okay, let us see how these vibrational and rotational levels are changed. Here, suppose we have rotational levels over here. The name of rotational levels are J, symbol J is used for them. This is basic level. J is equal to 1, J is equal to 2, J is equal to 3, like this. Okay, and all these are parts of vibrational level V0. This is vibrational level. Basic state and these are rotational levels. Rotational levels are fractions of vibrational levels. Okay, and then we have rotational levels of different level over here. Suppose these levels are J dash, which is equal to 0, J dash is equal to 1, J dash is equal to 2, J dash is equal to 3, etc. And this bunch is known as V1, vibrational level again, but of higher energy. Okay, so what happened? Here, molecules will move from one level to different levels. For example, from here, from third level of J, the molecule will reach to second level of this J dash. Okay, like this. So from second level it can reach to first level, and from first level it can reach to zero level, and this will produce lines which are known as P lines. Similarly, from second level of J, the molecules may reach to third level of higher level, that is from second to third, from first to second, from second to zero, like this. Okay, and these lines are called R lines. So this way we get bunch of lines because of this change or absorption of infrared. So here vibrations changes from V0 to V1. So molecules move from V0 to V1 simultaneously from some rotational levels to some different rotational levels. And this all will produce bands. And these bands are called infrared spectra. Okay, so when molecule absorb IR radiations, what happens? This molecule will reach from V0 level to new level, which is called V1. This is V1, it is an excited vibrational level. Okay, and there molecules have different distance. So here we will see that this distance is R1 dash, and now this new distance is R2 dash. Okay, so for excited state we will have a new distance R0 dash, which is R1 dash plus R2 dash upon 2. Okay, and molecule move from zero vibrational level to first vibrational level like this. And there are so many different vibrational levels along with this, like this, and it can reach to V2, it can reach to V3, etc. from 1 to 2 and 2 to 3 like this. So this way molecule when absorb infrared radiations, they move from zero level to first level, or first level to second level, or second level to third level, including rotations, change in rotations also. Okay, so this way we get infrared spectra, but there are so many lines which I have explained you here, and therefore in infrared spectra we will observe bands, not lines. Okay, because of so many lines over here, and that is why this is the nature of infrared spectra, like this. Okay, these are known as bands or dips. This spectra is a reverse of ultraviolet visible spectra. Okay, so this is what happen when molecule absorb infrared radiations. We get change in vibrations as well as rotations, and therefore we get bunch of lines, and this bunch of line merge and produce bands or dips, which is called infrared spectra. Okay, so that's it in this lecture. Thank you so much.